right, next lecture, work energy theorem. Pretty standard theorem of physics. But the main idea is that work, or energy, equals work equals force times distance, meaning like the distance you apply force over, and is also equal to the change in kinetic energy. And it states that kinetic energy is measured by 1/2 mv squared, I guess minus 1/2 m final or initial. M probably doesn't change. So all we're doing is looking at the difference between mv final squared minus m v initial squared, and that is the same thing as the force times distance, the same thing as work done in this scenario. And it's pretty standard idea where you just plug in different values v to find the distance, and you get a difference of joules, which is the same thing as the energy injected into the system, same thing as the work that is done. So yeah. Question 30 asks about comparing the work between accelerating a particle from 10 meters per second to 20 meters per second versus that of accelerating a particle from 10 meters per second to 30 meters per second. Okay, so the key idea here is that work equals the change in kinetic energy. It's the work energy theorem, and change in kinetic energy is 1/2 m1 v1 squared minus, or I guess this would be final minus 1/2 m initial v initial squared. That's the change in kinetic energy, which is the same thing as the work done in this situation. So the first scenario, work 1, we have a final velocity of 10 meters per second and a starting velocity of final velocity of 20 meters per second and an initial velocity of 10 meters per second. So the work done is going to be equal to 1/2, and mass is a constant. We don't really, the mass doesn't change. So 1/2 m times 20 squared minus 10 squared, which is 1/2 m times 300 joules. That's work 1. So the second scenario, it's going from 20 meters per second to 30. Work 2 equals same 1/2 m. In this case, we have a final velocity of 30 meters per second and an initial velocity of 20. So 30 squared minus 20 squared, which equals 1/2 m. 900 minus 400, this is 500 joules. And we can clearly see that in the second scenario, it takes more joules, more work to move the particle, to accelerate the particle, than in the first scenario. So I guess in the first scenario, it takes less work, meaning that the answer is A.